Hello, everybody. We are live from New Orleans. This is Lisa Salberg, and this is Tales from the Heart, a podcast from the Hypertrophic Cardiomyopathy Association. And as you can see, different set, but I still have my bricks. There's always the bricks in the background. I am joined by Whit MD, PhD, pretty smart guy, with Tenaya Therapeutics, and we have some really exciting news to share with you today. Yesterday, here at the American Heart Association, we got some data on Tenaya's project, TN-201, and this is gene therapy in hypertrophic cardiomyopathy for myosin protein C mutations. And you might remember, what was it, 2 years ago, October 4th, 2023, the very first patient was dosed in this clinical trial. And we will, in the second session later this evening, be joined by that first patient. But we're going to hear the readout for the first 6 patients and the Tenaya trial. Whit, can you tell us what's going on? I'm excited to hear this news.
Yeah, we're very excited. Dr. Desai, an international leader in hypertrophic cardiomyopathy, presented more data from the first trial of this gene therapy in patients with hypertrophic cardiomyopathy, and specifically patients with mutations in this complicated named gene MYBPC3, the most common genetic cause of the disease. And when that gene is involved, it means there's not enough of the protein by the same name, MYBPC protein. So we're happy to share data from the first patient's dose. We've used 2 doses. 3 patients have been treated with the initial dose, and then with the second dose, we talked about 3 more patients, and Dr. Desai did announce that a 7th patient has been dosed as well, not included in the presentation. But we are very encouraged that the gene therapy has been well tolerated. The delivery has been well managed.
So let's walk people through what the delivery means. How is it brought into the body?
Right. So importantly, it's a one-time treatment. So it's put in through a vein, an IV, just like getting a blood test. You put it in through the vein in the arm. And it is infused over a matter of just a few hours. And then that is all that's needed to deliver the gene to the heart. After that, the drug takes care of itself, gets the gene to the heart, and starts making this protein.
That sounds awfully fancy. It takes the gene to the heart. What is the mechanism that happens through?
Yeah, so the gene, which is made out of in a delivery package, like a FedEx package or a box, and it has a delivery address, which is to the cells of the heart. And then when the heart receives it, it opens the package. The DNA goes to the nucleus of the heart where the genes are active. The heart then knows what to do with it. The genes like the instruction. So the heart is missing the instruction manual to make this protein. It has all the parts it needs. Once it gets the instructions, it starts assembling the protein. And then, biologically, this package, the box, is made out of protein, and it's a protein that is borrowed from viruses. So viruses know how to deliver genes to cells. We take advantage of the mechanism that viruses use, but we remove all the viruses genes. So it's not like a virus. It's not infectious, can't be transmitted, doesn't cause disease.
So just doubling down on that for a second so people understand, you're not getting a virus like an illness virus. It is just the delivery mechanism is using the same mechanism that a virus uses to replicate in your body.
Just the protein parts from the virus, not the infectious parts.
Perfect. Some people are like, am I going to have to get sick to do this? No, this is not that way. Okay, so we've delivered this to 7, but we're reporting on 6 people. And what did we find out?
Well, we found out, one, that the gene is getting delivered to the heart cells, and it is getting turned on in the heart cells, and we see expression of the RNA, which then leads to the production of protein, and we've seen increases in the protein in the patient's hearts who have received the treatment. Encouragingly, and more important to your audience, that is leading to encouraging initial signs of benefits for the heart. And importantly, hypertrophic cardiomyopathy is manifested by too thick a heart, and we're seeing it thin. after treatment. And we can measure the severity of disease by biomarkers. Many of you may have had blood tests, for example, for troponin levels, and we see improvements in the troponin levels as well, which is a secondary line of evidence that not only is it working as expected to turn on and make protein, but that's having beneficial effects. Now, this is still an early stage in the study, and most of that data that we have now is coming from the first cohort, and we look forward to next year sharing more data from these additional patients that have been dosed in the second dose cohort, longer term follow-up. But we're very encouraged. We're exactly or where we would want it to be at this point, or even ahead.
Oh, even ahead. So you said a word that probably triggered the ears of most of our thick-hearted friends: thinning. You saw a reduction in hypertrophy in these patients. Can you discuss a little bit about that?
Yeah, the data that we shared, which is in a publication now too. Those of you that
drop here in the link so you'll be able to see that.
Yeah, we emphasize the posterior wall of the heart, and we see when we use echocardiograms, which many of you had, we actually see returning towards the normal dimension for the wall thickness in the wall of the heart.
So where is this hypertrophy going? Just disappearing. We're getting normal wall measurements. That's almost magical. It's crazy that we're able to do that.
Yeah, so we can, how is it happening? We can theorize on the mechanism. What we know from the disease is that each individual heart cell in the wall is bigger than a normal person's heart cell. So it's alive, it's working, but it's putting too much protein in there, and so it is hypertrophied or too big. So the most likely mechanism for reversing that process is that those proteins, now that they're making the MYBPC3 protein, have all the regulation of all of their proteins better, and they're regulating their size more in a more normal way. So
the cells
we don't know this. We don't have a way of really measuring that effectively. But that's the mental model we use, that the cells themselves could be coming back to normal size.
So gene therapies are new. We're just learning about them. A few have been approved already for other disease states, but this is the first time we're looking at HCM with gene therapy, and that makes it very exciting and a little scary because it's a new frontier. So as we're going through this process, we have to be really careful, and we have to work closely with the regulators to make sure that what we're doing makes sense and is safe. Can you tell us where you stand currently with the FDA?
Well, yeah, I will say it is a very exciting time. It's a rapidly growing field. There have been many approvals where gene therapy is working for patients with a variety of different diseases. Thousands of patients have been treated. And so I completely agree. We need to be very careful. But one thing that's very encouraging with our data is that there's no new or unexpected effects of our gene therapy. So we know from other gene therapies what to look for, and we know how to manage it. We do use immunosuppression. We talked earlier about why we're using proteins from viruses. The body thinks it's a virus, and the immune system gets turned on. So we do need to manage that, and we use medicines during that period. But our medicines have been effective in controlling the immune system. And in fact, as we learn and as we go, we've needed less medicine in the higher dose, the second dose cohort, to effectively control the immune regimen. So our safety progress is getting better and better. We are closely aligned with the FDA. Safety is our top priority. It's their top priority as well. They have had learnings from the field, which they're sharing with us. We are not dosing patients now as we refine the protocol, with their input and our input, to really codify or make the algorithms based on what we've learned so far and the improvements we've been able to make, get those written into the protocol so it'll be straightforward. All sites will know how to implement it in the same way effectively. So really appreciate the partnership with the FDA on that. We've had rapid back and forth, and anticipate we'll be, amending the protocol and dosing patients again soon.
Fantastic. Now, do you have the next patients lined up? If anybody's interested, you can still talk to your team and test it, or are you not looking for any other candidates at this time?
We have learned a lot. We would like to participate with more patients. We really appreciate every patient that joins us on this journey. We will ask for a few more to help us further understand. So we do plan to enroll several more patients going forward. We do have some patients waiting, some in line, some watching this data very closely. And I would say Dr. Desai's presentation has been well received, and we've had cardiologists come saying they have patients, and would they be able to enroll their patients as well. So we anticipate even more of a queue of patients waiting to participate. But if you are interested in the trial, certainly do reach out to your doctor to connect with one of the study investigators. We'd certainly be open to considering.
They're welcome to call the office as well, and we can align them with the right people if they're interested in getting involved. It's we want to talk about the full trial design and how long the full trial is going to be. This is an early readout. We're going to do more work to talk about the rest of the study.
Yeah, so the protocol for people choosing to participate is a 5-year protocol, but most of the assessments are done in that first year period. So the data that we shared involved that 1-year mark for the first dose cohort. Next year, we'll be able to share data for the 1-year mark for the next dose cohort. But if you're considering participating, there will be many visits and assessments, especially in the first 6 months, also in the first year. And then, by the 3rd year, it's just annual visits.
So out of the 6 patients, has there been any functional change?
So, we are encouraged that the strength of the heart is very stable. As we know, some treatments of this disease have problems with reducing the function of the heart, and we've had no issues with that. And we are encouraged by the improvements in the wall thickness.
Okay, fantastic. So what do you think the most important thing for patients to know about gene therapy in 2025 is?
Well, we are moving quickly. Many folks have the idea that this is many years away, but we are treating patients now. And again, there's development happening for many different genes and many different diseases. As members of companies, sponsors working on these, we do collaborate and align learnings and incorporate that just to maximize the chance that every patient that chooses to join us in the trial and participate has a chance to benefit and can be treated safely.
As a family with myosin binding protein C3, I'm watching very closely. Obviously, it's not going to work for me because my heart's in a box now. We can't treat her over there. Wouldn't do any good anyway. But there are thousands of people in the HCMA database who are MYBPC3, and we know that they want the opportunity to know a life free of HCM. Do you think that's possible coming up? We're going forward thinking, we're not going on the trial right now. Where do you think gene therapy is going to go?
Now, that is the vision, is to prevent disease. We are very encouraged by the reversing of disease that we've already seen, and we have been able to reverse disease in the animal models. But this would be ideally suited to prevent disease before a patient even has the first symptom or sign of disease. To get there, we want to know exactly what the right dose is. We want to be able to administer it as safely as possible, and we look forward to learning more about the durability. Other heart gene therapies before us have come out with a 3-year time point, and the gene is still on and active, and patients are still benefiting for 3 years, and that's just the beginning. Given the mechanism, with the DNA, we expect will be stable and the gene therapy effective for many years.
So when you say the DNA is stable, so we're talking, is it replicating itself constantly? How is that process?
Well, the advantage of gene therapy for the heart is we don't need the gene
to continue.
So it is a challenge for other organs where those cells are replicating frequently that can dilute out the gene. Heart cells don't divide after the first week of life. When we were 1 week old, we got all of our heart cells, and there's no more division. and so we don't need the DNA to divide. When the package delivers the DNA to the heart, it forms a stable structure called an episome, which acts like a chromosome, which is stable long term.
Fantastic. If you have any questions, we don't have a lot of online viewers right now, but we're going to get questions later, I'm sure. You're welcome to drop the questions either now or afterwards. We can pick them up, or you can contact the office at support@4hcm.org, and we can field any questions over to our friends at Tenaya and answer anything that you might have if you're watching this after, God, what is today? It's November 9th. I don't even know what day it is. And it is 4:20 Central Time, or 5:20 Eastern Time. My computer's on one time and I'm on another. What else do we need to know? What's happening next? Is there any additional trials coming, or what is the pathway if we continue to see success here? How long is this process going to be until it might get other people?
Yeah, so as I said, we are planning, as we're aligned with the FDA, of including a few more patients in our trial and seeing how that data matures, especially the key 1-year time point, and even how the second year goes for our patients. And that will very much help us design the next trial, which we anticipate would be what we call a pivotal trial, would be to support approval so the drug could be used in clinical use in the future.
I do have a couple of other questions, but I'm going to leave them for another podcast because I really want to stick to the trial today. But we'll have you come back at another time to talk a little bit more about the future of gene therapy. And for those of you who are interested in this topic and want to share your input with us, on April 23rd, 2026, the HCMA will be holding an externally led patient-focused drug development meeting specifically on gene and RNA therapies in HCM. And we know many of you have been challenged with the diagnosis, a lot of complications. We want to make sure that we're creating a path to a future that could be a time when we can get a shot and get rid of our HCM. That is a big dream. It's a long way off, and it's not going to be for everybody because you need to have a targetable gene, you need to have a therapy that gets there. So it's not going to be for everybody, but it could be curative for some. So we want to talk to the FDA as a patient community and explain what our risk tolerance is, what our burden of disease is, and why we feel so strongly that this work must continue and that we must find a path forward to an ultimate someday, word I never thought I'd say out loud, cure for HCM. Oh, we have some questions coming in and I don't have glasses on. Glasses back on. Oh, hi, Fabian. Thanks for all the information. Will there eventually be international clinical trials? International genetic therapy, is it something on the...
Absolutely. So the current trial only has U.S. Centers. Some of those centers will accept patients coming in from other locations. And so we're international in that sense now. But future trials, we very much hope to go to more regions, more countries.
Fantastic. Great question, Fabian. Thank you for that. Global reach is going to be important for everything. Global affordability is going to be something that we're all going to struggle with, how to make that happen. We are living in some very interesting times on many levels. But guys, I just got to tell you, this is coming in. This AHA had the most content on HCM at the highest level I've ever seen. Like, we are not talking like, let's describe the anatomy and what is obstruction and what is the mechanism. We are talking about genetic therapies. We are talking about targeted therapies. We are talking about everybody. I saw data on women with HCM and men with HCM and kids with HCM and all the different types of thick hearts that HCM looks like, breastopathies, Fabry's, amyloidosis, HCM. We are front and center here at AHA. And I have some other updates to give you that have nothing to do with gene therapy, so we're not going to take Whit's time today to talk about that. But it has been exciting.
Yeah, I mean, even Dr. Desai's presentation was in a room called Main Event.
Yes, it was the main tent, yeah.
It was very front and center. So that's terrific.
from the last day of the session at the furthest room away from like basically the most inconvenient place that we could be, that's where we used to be at HCM. And I look around and the rooms are filled, and HCM Society had over 330 participants. The rooms for all the HCM talks are filled. There's interest, there's excitement. It's a good time to have a thick heart.
And I do want to put you a shout out for the patient-focused drug development day. I mean, we rely on patient input. I'm a cardiologist. I know that doctors sometimes have one set of priorities, and patients are, sometimes there's not as much communication as there could be.
Right.
We at Tenaya, and I know fellow sponsors as well, very much want to be doing today what patients need next, and we want to hear from you exactly what it is that you feel you need and what we should be measuring in our trials to determine whether we're achieving those objectives. And I know that FDA clearly shares that.
And while it's complicated right now in the landscape that we're living in, all of the people that I've worked with at the FDA, whether it's a molecule or gene therapy, they really do appreciate our feedback, and they want to know what patients think and want. And it's critically important that we're clear with them on what is important to us. And we do that with full transparency. It's all out there, and we're talking about our real lives and what we really want. I think one of the most challenging questions is going to be for patients and families with HCM, should this become approved? Like, we're going to go forward thinking here. When is the right time? And clinicians are struggling with this, patients and families are struggling with this, and we're all going to have to work together to figure that out. And I don't know how long it's going to take us to get there, and I know I'm going to be asked a lot of questions. Well, if it's available, when should I do it? And that's going to be a very individualized conversation, shared decision-making at the highest level possible. And I really think it's going to be important to document how we get there. And what's right for one family may not be right for another family.
Yeah, I think that's well said. I mean, we are fully committed to determining what is the best time from a science perspective, from a mechanism perspective. Is there a time that's too late, the disease is too advanced? Is there a time that's too early? We will use clinical trials with the help of the participants and patients participating to find out what is the window where it is most effective. We anticipated a pretty wide window, but obviously there are going to be many other considerations for each patient about when it might be right for them or their family member.
So, kind of a wrap-up last thought, or almost last thought. I would say about 22, 23 years ago, kind of had this idea that we needed more centers. And as we started to develop more centers, the idea was if we built more centers, we'd have more patients siloed for clinical trial possibilities. It may have taken over 20 years to get all of that built and have some real good clinical trials done within those centers. So I'm super proud to say that the patients that have been dosed so far have all been dosed at HCM recognized centers of excellence. So my forward-thinking views actually manifested into reality. And I didn't know who was going to come along and do the thing. And my gratitude to Tenaya and your entire team for all the great work that they're doing to try to bring therapies to our patients. And I thank you for running away from the convention center to come to our Airbnb and talk a little bit about this amazing clinical trial. Thank you so much.
And thanks to patients who have participated in a whole variety of trials for a whole different mechanism. This is a fantastic AHA with more data than we've ever seen from clinical trials. The biggest hypertrophic cardiomyopathy trial reported out this year. Unfortunately, not a success for non-obstructive patients.
Not for BMS.
Yes, more to come with more trials. I have optimism for that. But importantly, so much important information from that trial is being incorporated, certainly into how we hope to help non-obstructive patients, but I know for other programs as well. And this can't happen without participants in trials. So thank you.
It cannot happen without all of you, whether you're watching as a clinician, a member of industry, a patient, a family member, somebody interested from the general population. This is amazing times. The science is moving very quickly, but very effectively. It may seem like it came out of nowhere, but a lot of people have been working behind the scenes for a long time to bring this into fruition. And I will say back in 2002, the Seidman Laboratory came down and did an evaluation on my family because we couldn't find our gene. And my entire family showed up and commandeered the imaging of Morristown Medical Center. We just kind of took it over. Thanks, guys. And we screened our whole family. My whole family gave blood. We found myosin binding protein C3 mutation. I was the index patient. We found it in my dad and many other family members. And the generations continue. And we continue to find this gene within our family. So having a potential pathway that it doesn't have to be as it was is really inspiring. So thank you to all for having the power and the, this is hard work. I know Melinda, tough Melinda, says he didn't sleep the night before the first dose. And he was doing a really big thing. It didn't seem like much if you looked at the moment. A doctor comes in and an infusion is given to a patient. It happens a million times every day. But this infusion was different. And we're going to hear her story in just a little while. So join us back here in a few minutes. And Julia will be arriving shortly. They're not here together, as that's not the way we did this. We're separate. So we're going to close down this episode, this brief episode of Tales from the Heart. We will be bringing you more information on genetic therapies coming up. If you're interested in sharing your perspective on what you think about gene therapy, we will be putting out a survey shortly, probably in about 2 months, on what your thoughts are on gene and RNA therapies. I'm not sure a lot of our people really understand RNA therapies yet by RNA silencing. So we're going to have to do some education before we ask you questions. So we're going to get to that too.
Please stay on for that.
Yes.
Podcast with Julia. She's the first patient to ever receive a gene therapy for IBPC.
They're going to love her.
Cardiomyopathy. I got to meet her yesterday. She's a hero, really.
I called her a little pioneer.
I know that she did this not just for herself, but to help all her fellow patients. I'll let her give the quotes.
I'm getting chills even thinking about it. You guys are going to love her. So come on back in a few minutes and we're going to talk to Julia. Whit, thank you very much. And again, thank you to everybody at Tenaya. And 3, 2.